So far, we have described motion in a very direct sense, using vectors to describe the velocity, acceleration, force, and momentum of an object at any instant of time. Another way to think about motion is to consider the state of the object at an instant of time. State here just refers to the details of the object, such as how fast it's moving and where it is. To be complete, we could also include details like how warm it is, the object's shape or configuration, its chemical composition, and so on. The point is, for every category we can assign a value, and when we total up all of these values, we can quantify the overall state with a single number. We call this number the total energy of the system. Each category then is a specific type of energy. For example, potential energy is based on the position of an object. For gravitational potential energy, what matters is the elevation of the object. So this energy depends only on the vertical position, y. Kinetic energy, on the other hand, quantifies the motion of the object. It doesn't matter where the object is, only how fast it's moving. And notice that the kinetic energy depends on the square of the speed, so there's no directional information in the kinetic energy. Other details of the state of the object are associated with their own types of energy, and we will encounter some of these later in the course. Now, to take a quick look at the formulas for these two energies, you'll find that the SI units are kilogram meter squared per second squared, which we call joules. These are also the same units as work. When we look at the motion of an object, the kinetic and potential energies will vary from place to place. However, under the right circumstances, the total energy of the object will remain constant. As long as no work is done to the object by a force, the energy is conserved. This gives us a description of the motion. For example, we can use conservation of energy to determine how high or how far the ball travels. Try this next question, and then we're going to take a look at a demonstration of conservation of energy.